Hello everyone. We're going to go over basic principles for making solutions at certain concentrations with certain solutes. One of the basic ways to begin is to make sure you have everything ready before you get started. So some of the things you're going to need are graduated cylinders, beakers, magnetic stir bars over the magnetic machines that stir our solution and mix them. We are going to make today a 2 molar calcium chloride solution, which we use to transfect cells, different types. You can put plasmids and different type of nucleic acids in. So it's something that's readily used regularly in different types of labs. What we're going to do today, you can pretty much apply to a lot of things you're going to mix. In terms of concentration, molarity is used for various solutions and solvents that are molarity is the basic unit of concentration. So when somebody talks about grams per mole, grams per liter, they're usually all mixed where they're all talking about a certain amount of a substance in a liquid. So one of the first things we need to consider when you walk into a room and you're going to start mixing chemicals with solutions, it's how many grams you need over how much volume. So we're gonna figure this out using basic formulas, which are just two formulas. You might have gone over this, but if not, it's fine. It's pretty much molarity, which you can figure out by how much you totally need in volume. It's going to give you moles, and from the moles, you're going to figure out the big question mark, which is how many grams to use. Okay, so let's get started. So since our chemical information gives us all this information, it also gives you molecular weight of your particular substance, in this case, which we're using, which is calcium chloride. So we essentially need to make 2 molar, and our question mark for the first formula is how many moles do we need, and we have 100 mils that we're going to make total, which is 0.1 liters. So then when you do your algebra, you pretty much multiply your molarity times the amount of volume, which gives you how many moles you need total to make 100 mils of your calcium chloride, 2 molar calcium chloride. Then you carry over the moles, and moles, as we all know, is equal to grams over molecular weight, and this is what we need, is the amount in grams. So since we need 2 moles, this is our question mark over the molecular weight, which is 110.98, which our bottle gave us. We do the algebra where we multiply, and now we need 22.2 grams of calcium chloride in 100 mils to make our 2 molar solution. So right now we have the amount in grams of calcium chloride and in the amount of solution that we have. So we've answered our 2 questions, and we have our reagents ready to go. So all we need to do is start mixing. All right, so we have a weigh station, a weigh boat, and what we're going to do is we're going to put our weigh boat over, and we're going to blank it, or zero it, or whatever they call it, or tear it. And as you notice, it's not taking into account now the weight of the boat, but only of our pure substance. So we're going to pour out until we see 22.2 grams. We're at 21. 21.2. Let's get a little bit. Perfect. So now we're at a little bit over. But let me scoop some out. I got a little spatula here. I mean, I really shouldn't do this, but hey, I guess we're trying to save money. All right, so now we're perfect at 22.2 grams. We're going to put our chemical back to where it belongs. So now that we have our calcium chloride weighed out, we're going to put out 100 mils of solution. We got our graduated cylinder, and we're going to just get it right at 100. You see right there, we got 100 mils solution. Pretty good, not bad. We're going to pour it right into our beaker. Want to get it all in there, and then we're going to start Getting our magnetic stir bar in action. Here, let's plug it in. And now we're gonna see if it's working. Oh, this isn't even working. Oh no, this one works. Yeah, this one works. Perfect. Yes, this one works. So now it's gonna start stirring, and it's stirring a little too violently. Let's lower it a little bit. You want to get a nice stir, non-violent. You don't want to, and then we're just going to pour our 22.2 grams right in there. You want to get all of it out. So I give it a little, tap it a little bit. As you see, our next stir bar slow down a little bit, and that's because there's a little bit of stuff in there. As you see, it's dissolving, it's going into solution. It's actually exothermic, so you start to see a little bit of heat transpire, a little bit of, oh, I went too far. Did I go back? All right, so we're just basically gonna let this go until the solution turns clear, and then we can bottle our stuff up. So this was basically how we mix in the lab. It's pretty simple. As long as your math is correct and you have everything you got, there's nothing to stop it. Look, now it's turning clear. Perfect. Okay, guys. Thank you so much. Hope you guys learned a bunch. See you next time with another lesson.